Welcome back to the deep dive. It's really great to have you with us. Today we're doing something a little bit different, and honestly, I think it's going to be surprisingly cool.
Yeah, it's definitely a change of pace from the usual.
Right, because usually we're tackling, a huge stack of articles or a heavy nonfiction book or maybe some complex piece of legislation. But today, our source material is purely visual.
It's a completely different kind of text, isn't it? We're basically reading the landscape today.
Exactly. We have this series of 10 high-resolution photographs, no text, no captions, just the raw visual data. And they aren't artistic landscape shots or family vacation photos. We are looking at a construction project.
Right.
Specifically, a road being built in what looks like this beautiful, lush, tropical coastal environment.
Which I know might sound dry to people initially. Like,
Yeah.
oh, photos of a road. Thrilling.
Yeah, exactly.
But I think that's the trap we fall into. We treat roads as the absolute most mundane things in existence. They're just the background of our lives. The gray space between point A and point B.
Right, they're completely invisible until they break.
Precisely. But when you actually stop and look at the guts of a road being built, which is exactly what these images allow us to do, you realize it is a massive, incredibly complex machine.
Mm-hmm.
It's not just a layer of rock. It's this complex sandwich of chemistry and physics designed to fight two things that basically never sleep, which are gravity and water.
Wow, I love that. A machine to fight gravity and water. And really, that is our mission for this deep dive. We want to develop a kind of an X-ray vision for you. We want to look past the surface of the road, that gray ribbon that we drive on every single day, and understand the engineering, the logistics, and the storytelling that is embedded in these layers of dirt, steel, and concrete.
And by the end of this, I promise you, you won't look at a construction crew in your neighborhood the same way again.
Yeah.
You'll actually see the battle plan.
So let's jump right into the before picture, or at least the start of this transformation. We are looking at image 1 and image 9 in our stack here. If you can picture this, the setting is just vivid. It practically screams tropical.
It really does. Looking at the background of image 1, you see these steep, lush, green hillsides rising up. There are palm trees, dense shrubbery, these broadleaf plants everywhere.
Yeah.
This isn't a dry desert highway. This is an environment that is very alive.
And inhabited, which is key. In image 1, right in the background, there's this bright lime green wooden house with white trim. It's incredibly charming. It feels very Caribbean or maybe a Pacific island. It has a lot of personality.
Yeah, it's just a community. This isn't a road in the middle of nowhere.
Mhm.
People live here. They paint their houses bright colors. They clearly care about their space.
But then you look at the ground in front of that house.
And the ground tells a very different story.
It is an absolute mess. In image 9 specifically, we get a real sense of what driving here actually feels like. We see a silver hatchback. It looks like a Toyota Vitz or a Yaris, that classic reliable island car, and it is navigating this absolute moonscape.
Moonscape is definitely the right word for it.
It's unpaved, dusty, full of these jagged dips and rocks. You can practically hear the suspension clunking just looking at the photo. The car is tilting forward, nosediving into this huge depression in the dirt.
That image 9, is really the thesis statement for why this whole project is happening. This is what we call the infrastructure gap. You have this incredible natural beauty, the green hills, the vibrant community represented by that greenhouse, but the connective tissue, the road, is failing.
It creates such a sharp contrast. You see the silver car dipping down from a section of what looks like existing concrete directly onto this rough dirt and gravel. It's a jarring transition. It looks like you'd spill your coffee immediately just hitting that bump.
And think about what that means for the people living in that greenhouse in image 1.
Yeah.
We were looking at it on a sunny day in these photos. But in this specific climate, when it rains, it pours.
Oh, right. That dirt isn't going to stay as dust.
Exactly.
Yeah.
Before this construction started, every time it rained, that dirt road likely turned into a slurry of mud, a complete quagmire.
Yeah.
Getting to work, getting groceries, getting emergency services, and it all becomes a struggle against the terrain itself. If you have a medical emergency and the ambulance gets stuck in the mud, that's not just an inconvenience, that's a tragedy.
Right. So when we look at these construction photos, we aren't just looking at cement being poured. We're looking at accessibility. We're looking at a literal lifeline.
It's about dignity, too. Having a paved road means you aren't dragging mud into your house every single day. It means your car lasts longer. It means you are connected to the rest of the world reliably.
Speaking of connecting to the rest of the world, there's a bit of a mystery destination involved here too, right?
Hmm.
If we peek ahead at image 10, the whole vibe changes completely.
The destination.
Yeah, we see this very dark, manicured wooden gate. It looks expensive. And there's a tasteful little sign reading Hermitage Bay.
It's a really stark contrast to the open, messy construction site we see in all the other photos.
Right. It's got dense manicured landscaping. It's very private, very enclosed. Interestingly, the driveway inside the gate isn't even concrete. It looks like crushed stone or gravel, which ironically is often a sign of high-end luxury in these types of environments.
Right, it suggests an economic driver at play here. You have a high-end destination, likely a boutique resort, or maybe a private residential community, sitting at the end of this road.
Hermitage Bay certainly sounds like a place where people pay a lot of money to go and relax.
It does, and honestly, that is often how infrastructure gets funded in these remote or geographically challenging environments. The local municipality might not have the budget to pave a complex mountain road on their own. But if you have a resort at the end of the road that needs to get their guests from the airport to the lobby in comfort,
Then the resort writes a check.
or they lobby heavily for it, or it becomes a public-private partnership. The road connects the local community, like the folks in the greenhouse, but it also serves the economic engine of that destination. It acts as a dual-purpose artery.
It's interesting to think about that shared space. The worker driving that Toyota Vitz and the tourist in the luxury shuttle are both relying on the exact same engineering to get where they're going.
Exactly. The concrete doesn't care who you are. It just needs to hold the weight.
So we have the setting established. It's tropical, challenging terrain, a mix of local life and high-end tourism. Now, let's get into the anatomy. Let's put on our hard hats and look at the skeleton of this thing. I want to go back to image 1.
Okay, back to the greenhouse.
Yes, but look at the foreground this time. We completely ignored it before to look at the house, but there is a massive trench dug out on the left side of the frame. And sticking out of the dirt is this large, black, corrugated pipe.
Ah, yes, the pipe. This is arguably the most important part of the entire road.
The pipe, really, more important than the concrete.
Absolutely.
Yeah.
If you look at image 1, that pipe is a culvert, likely made of high-density polyethylene or HDPE, and the trench is the beginning of a comprehensive drainage system. Here is the golden rule of civil engineering, especially in a tropical environment. Water is the enemy.
I always thought heavy trucks were the enemy, or maybe, I don't know, tree roots pushing up.
Heavy trucks are a challenge for the surface wear and tear, definitely. But water. Water is a challenge for the very existence of the road itself.
How so?
It comes down to soil mechanics. The dirt underneath the road, what we call the subgrade, provides all the support. When that soil is dry and tightly compacted, it's incredibly strong. It pushes back against the weight of the cars. But if water gets under your road and saturates that soil,
It turns to soup.
exactly, the soil particles separate from each other, the structural integrity just vanishes. It literally becomes mud. So now you have this heavy slab of concrete creating a bridge over essentially nothing, or over mush,
And then a truck drives over it.
and snap. The concrete cracks right down the middle because there is absolutely nothing supporting it from below. So that pipe in image 1 tells us that before they poured a single drop of concrete, they had to figure out exactly where the water goes.
It's like plumbing for the earth.
Precisely. They are channeling the runoff from those lush hillsides so it goes under the road, through that culvert, and out the other side safely, rather than flowing through the road foundation or washing over the top of it.
So that black pipe is basically the bodyguard for the entire project.
It really is. If they skip that step, this road would be completely destroyed within a year.
Moving on to image 2, we see the ground has been cleared. It's this flat, brown, compacted strip. It looks like they've taken a giant razor and shaved the earth perfectly flat.
That's the roadbed or the subbase. And this goes back to the organic material issue. You see the grass and the bushes on the side. You simply cannot pour concrete on top of grass.
Because the grass dies.
Grass dies and decomposes. And when it decomposes, it shrinks and leaves a void. An air pocket. You absolutely do not want air pockets under your road. So step 1 is what we call grubbing and clearing. You scrape it all down to the mineral soil, the rock and clay. Then you compact it until it is rock hard.
So that's the foundation.
That is the canvas. Everything else relies on that dirt being perfectly stable.
Okay, so we have the pipe for drainage. We have the flattened dirt for the base. Now let's talk about the metal, because this is where it starts to look like a sci-fi skeleton to me. In images 2, 4, and 6, we see these rusty wire mesh grids laid out all over the dirt.
Ah, yes, the classic 6x6 welded wire mesh.
It looks so flimsy, though. It's just this thin grid of rusty wire. Honestly, it looks like fencing you'd use for a chicken coop. Why is that necessary for a road that carries 2-ton cars?
It's all about the inherent weakness of concrete. We have to understand that concrete has a bit of a split personality.
A split personality.
Yes, concrete is an amazing material. It has incredible compressive strength. You can park a fully loaded semi-truck on a block of concrete, and it won't crush it. The truck pushes down, the concrete pushes back. It's perfectly happy. It loves weight.
Okay, so it handles the squishing just fine.
Right, but concrete has terrible tensile strength. It hates being pulled apart, twisted, or bent in any way.
Like if the ground underneath it shifts.
Exactly. If the ground settles even slightly, or, and this is huge, if the temperature changes.
Thermal expansion?
Right. In the tropical sun, that road gets extremely hot. It expands. At night, it cools down and shrinks. That constant movement creates tension. Without help, the concrete creates these jagged, ugly cracks and just falls apart. It's very brittle on its own.
So the wire mesh helps with that?
The steel is the partner. Steel is great at handling tension. It's ductile. It can stretch without breaking. So that wire mesh you see in image 2 creates a composite material. The steel acts as the skeleton inside the rock.
So if the concrete tries to crack, the steel is there to hold it together.
Exactly. It acts like a suture or a stitch. Even if the concrete develops micro cracks, which it absolutely will, the steel holds the two sides of the crack tight against each other. It keeps the road from breaking into separate floating islands of rock.
It's almost like the rebar is holding hands with the concrete.
That's a really good way to put it. A very, very strong grip.
Speaking of rebar, look at the right side of image 2. It's not just the flat mesh there. There is a really complex boxy cage structure made of thick steel bars being built up on the side.
Yeah, that's very distinct from the flat mesh. It stands up vertically. It looks almost like a long rectangular tunnel made entirely of steel.
Why the massive upgrade in heavy metal right there?
That tells us there is a retaining function happening. That cage is likely for a heavy-duty drainage channel or a retaining wall edge. That is pure 3D structural engineering at work.
This is on a hill.
Right. Look over at image 7. The road is cut directly into a slope. Gravity means the earth wants to slide down. That steel cage is going to be encased in concrete to withstand lateral pressure, meaning soil pushing from the side, not just traffic pushing down from the top. It acts like a massive beam buried in the ground to hold the entire edge of the road in place.
Wow. I noticed in image 6, which is a really tight close-up, the mesh looks really rusty. I mean, it is bright orange.
It is very vibrant, yes.
Is that bad? I feel like if I bought a brand new car and the frame was that rusty, I'd return it immediately. Did the crew just leave it out in the rain for too long?
They definitely left it out in the rain, but here's a little secret of construction for reinforcement steel. A little surface rust is actually a good thing.
You're kidding!
Not at all. Obviously, you don't want flaky, deep structural rot where the metal is literally dissolving. But that surface rust, that orange dust, it creates a necessary texture. Yes. It increases the surface area and the roughness of the steel. That helps the concrete bond to it physically. If the steel were perfectly smooth, like polished stainless steel, the concrete is slippery against it. It might just slide right along the bar when put under tension.
And you want them to lock together completely.
You want them to be inseparable. The rust helps them grip each other tightly. It's basically nature's primer.
That is fascinating. So the ugly orange rust is actually contributing to the structural integrity.
Within reason, yes.
Okay, let's move to the actual construction process itself, because the logistics of this are wild to me. If you look at image 2 and image 4, they aren't building the whole road at once.
No, they can't.
In image 4 specifically, you have this incredibly stark line down the middle. On the left, you have a pristine, white, fresh concrete lane. On the right, it's just brown dirt. It looks like a half road.
This is the maintain traffic flow challenge. Remember the greenhouse? Remember Hermitage Bay?
Yeah, people still need to get there while they build it.
Exactly. You cannot just put up a road closed sign and shut down the only access road to a community for 3 weeks to let concrete cure. The hotel would go out of business. The people in the greenhouse couldn't get food or go to work.
So you have to do surgery while the patient is awake?
That's a perfect analogy. You have to do this highly choreographed surgical dance. You build one lane, the left lane in image 4, while all the traffic drives on the dirt on the right. Then, once the left lane is strong enough to bear the weight, you shift all the traffic over onto the new concrete.
And then you tear up the dirt lane and build the second half.
Exactly.
That sounds like a total nightmare for the workers. You have active traffic passing you just a few feet away while you're pouring wet cement.
It is high stakes, for sure. It requires constant vigilance, but it also creates a really significant engineering challenge.
Mm.
Look closely at the seam in image 4.
You mean the line right between the white concrete and the dirt?
Yes, that exact line is called a cold joint.
A cold joint.
Think about it. You have the left lane. It has been poured, it is cured, it is rock hard. It is literally cold. Then, a week or two later, you come back and pour wet, warm concrete right next to it to form the right lane.
Do they just stick together?
Not naturally, no. Concrete really does not want to bond to old concrete. It's a massive weak point. It's like trying to stick a fresh piece of tape onto a very dusty surface. It just peels right off.
So how do they fix that? Because I don't see roads splitting straight down the middle usually.
If you look at image 6 and image 8, you can see the edge of the slab that they poured first. It's really rough. It's jagged. And you can clearly see the wire mesh sticking out of the side, just hanging out into empty space.
Yeah, in image 6, it looks broken almost, like they did a really sloppy job finishing the edge.
That jaggedness is highly intentional. That's a technique called keying in.
Keying in.
By leaving the edge incredibly rough and exposing the aggregate, the stones inside the concrete, and leaving that wire sticking out, they're creating a puzzle piece. They're dramatically increasing the surface area.
So when they pour the second lane,
The wet concrete flows right around those jagged rocks. It grabs onto that exposed wire mesh. It flows into all the tiny nooks and crannies. It locks the two lanes together physically and mechanically.
so it stitches the two halves into one solid unit, even if they don't chemically bond perfectly like a single pour would.
Hopefully, yes. If done right, the driver never even feels the seam. It acts as one continuous monolithic slab under the tires.
You mentioned aggregate just there. In image 8, we get a really extreme close-up of the material. It's not just a smooth gray paste like you might imagine. You can clearly see little stones, pebbles, sand.
That is the recipe. Concrete is basically just a glue, which is the cement powder and water holding together a filler, which is the sand and stone.
See, I always thought the cement was the strong part.
Actually, the stone, the aggregate, provides the bulk of the compressive strength. It's the true skeleton of the mix. And it's also significantly cheaper than cement. The real art of making concrete is getting that mix exactly right so it flows when you pour it like a liquid, but turns to solid stone when it sets.
Image 8 really shows you that texture well. It's a composite material in itself, just like the concrete and steel is a composite structure. It's literally rocks glued together with artificial rock.
Exactly.
I want to talk about the surface now. The tires actually touch. In image 5, if you look at the finished section, it has these very distinct horizontal lines. It looks like someone took a giant push broom and dragged it across the wet concrete.
That is exactly what they did. It's a very common technique called a broom finish or tining.
But why ruin the smooth surface? Wouldn't a perfectly smooth road be better? Like driving on a marble floor?
A smooth concrete road is a literal death trap.
Oh, okay. Why?
Think about the environment again. Palm trees.
Yeah.
Green hills. This is the tropics. It rains here and it rains hard. Sudden massive downpours.
Right.
If that concrete were polished smooth, the very moment water hit it, it would become a slip bend slide. The water would just sit on top of the concrete as a thin, unbroken film.
Hydroplaning.
Instant hydroplaning. Your tires would have zero grip whatsoever. You would slide right off the side of the road.
So those grooves are strictly for traction.
Yes. They increase the friction coefficient. But even more importantly, those grooves physically channel the water. They give the water a place to go so it doesn't sit as a film between your tire and the road. The water squirts down into the grooves, which allows the rubber of your tire to maintain contact with the concrete peaks.
It's just amazing that something as low-tech as dragging a broom over wet mud is a critical, life-saving safety feature.
It's pure physics applied with a very simple tool. And you can see the direction of the grooves in image 5 runs across the width of the road.
Right, sideways.
That helps drain the water off the sides quickly toward the gutters. If they ran lengthwise down the road, they might actually track your tires, kind of like driving on trolley tracks.
Speaking of gutters and sides, let's look at image 3 and image 7. In image 3, there is a distinct, completely smooth strip being poured on the far left. It looks separate from the main road.
That looks very much like the sidewalk.
And in image 7, on the right side, there is this crazy cage of rebar again. It looks like a long trough.
This is all about the segregation of flow. The road, the rough, broomed part is for the cars. But a road isn't just for cars, especially in a community like this one. We saw the pedestrian walking in the distance in image 7 earlier.
Right, carrying a bag.
You don't want them walking on the road if you can help it. So image 3 shows the sidewalk construction. It creates a dedicated safe zone.
But image 7 is fascinating to me. That rebar cage is likely for a substantial gutter or drainage channel, right?
It creates a highly defined path for the water.
Why does a gutter need so much steel, though? It's just water.
Fast-moving water is incredibly heavy and unbelievably destructive. We really tend to underestimate it. A cubic meter of water weighs a ton, literally 1,000 kilograms. If that water is moving fast down a hill during a storm, it has tremendous kinetic energy. It could rip standard concrete apart easily,
So you have to reinforce the gutter just as much as the road itself.
sometimes even more so. And also, as we discussed earlier, the gutter might act as a retaining wall for the slope next to it. It has to hold back the earth. So they are building a heavily reinforced concrete channel to guide that water safely away from the foundation.
Just visualizing the flow of all this, is the road perfectly flat?
No, the road is crowned. It's slightly higher right in the middle.
Like a turtle shell.
A very, very flat turtle shell, maybe a 2% slope from the center to the edges. That gravity forces the rainwater to run off the broom's surface into the rebar reinforced gutter we see in image 7, and eventually down into a culvert, like the black pipe we saw in image 1. It's an entire interconnected system.
Let's zoom out a bit to the finished product. We have image 5 again and image 11, which gives us a really nice, wider view. It's this gray ribbon cutting cleanly through the green landscape.
It looks very clean. It imposes order on the relative chaos of the jungle around it.
I noticed something else in the finished sections, though. There are these perfectly straight lines cut across the road every few yards, like someone took a giant circular saw to it after it dried.
Those are called control joints.
Control joints.
Here is a hard, unavoidable truth about concrete.
Yeah.
It will crack. There is absolutely no stopping it.
Wait, you can't prevent it? With
Yeah.
all that rebar?
You cannot. As it cures, it shrinks naturally. As the temperature changes, it expands and contracts. The earth below it moves slightly. If you just poured a continuous mile of concrete, it would crack entirely randomly, like a shattered windshield or a spider web. It would look terrible and it would crumble quickly.
So you just cut it on purpose?
You cut it to tell the concrete exactly where to crack. You weaken the slab in a perfectly straight line so that when the internal stress builds up, the crack happens nicely and cleanly inside that groove where you can't see it.
That is deeply philosophical. You're going to break, so break exactly where I tell you to.
Honestly, engineering is often just about managing failure rather than pretending it won't happen. By controlling the crack, you keep the surface looking neat and you maintain the structural integrity. The interlocking aggregate inside the crack still transfers the weight of the cars across the gap, but the surface stays perfectly smooth.
Let's talk about the human element again. We've looked at the steel and the stone all day, but image 9 really sticks with me. That silver car.
The Toyota Vitz.
It's just such a visceral image of the in-between stage of development. You can see the paved section ending so abruptly. There is a little ramp of dirt and then, bam, massive potholes.
That driver is literally feeling the difference between developed and undeveloped infrastructure right in their spine.
Literally.
But think about the profound change. Once this road is done, that daily car trip changes completely. Less wear and tear on the vehicle, much faster travel times. In image 1, the greenhouse, suddenly their property value likely goes up. The dust finally settles, the mud completely disappears. It changes the basic hygiene of the entire neighborhood.
And looking at image 7 again, that pedestrian, right now, walking on the side of that construction site is probably super annoying. It's muddy, there are loud machines everywhere, but once that sidewalk from image 3 is completely finished,
They have a safe, permanently separated path. They aren't dodging cars in the mud anymore.
it creates a real sense of place. A dirt track is just a way through. A road with curbs, gutters, and sidewalks is a street. It implies a certain permanence. It implies that the community is worth investing in.
Exactly. It signals very clearly that this place matters.
And then we have the destination connection. Hermitage Bay, image 10.
The dark wood gate.
It looks like a portal to another world. The visual language of the gate, the dark wood, dense privacy landscaping, paved entry is so completely different from the open public road.
It is. But the road we've been dissecting this whole time is the umbilical cord for that exact place.
How?
High-end tourism requires incredibly reliable infrastructure. You can't have guests paying top dollar if they get stuck in the mud on the way from the airport. They want the rustic, untouched experience once they're inside the gate, but they demand the modern, seamless experience getting to the gate.
So the resort likely pushes for or even directly helps fund the road construction.
Almost certainly.
Mm-hmm.
And the local community gets to piggyback on that investment.
Piggyback in a good way.
Yes, absolutely. The culverts, the drainage, the sidewalks, everyone in that area benefits from the heavy engineering required to get the wealthy tourists to the gate. It's a shared ecosystem. The concrete in Image 8 connects the modest greenhouse in Image 1 directly to the luxury gate in Image 10.
It's fascinating how 10 photos of just a road construction site can reveal so much. We've got hydrology with that black pipe. We've got material science with the rust and the aggregate. We've got complex logistics with the half-road pour. And we've got sociology with the housing and the resort.
It really validates the whole idea of looking closer. If you just drove past this site at 30 miles per hour, you just see road work and probably be really annoyed by the delay.
I would definitely be annoyed.
But when you freeze frame it like we did, you see a master battle plan. You see the strategy to keep the road from literally washing away into the ocean. You see the deliberate choices made to keep the community functioning during the build.
And you see the layers. I think that's my biggest takeaway from all this. A road isn't just the ground, it's a thing that sits on the ground.
It's a structure. It's essentially a bridge that just happens to be lying down flat.
That is a great visual. A bridge lying down.
Think about the rebar in Image 7 again. The huge cage. That's the exact same kind of heavy reinforcement you'd see in a high-rise building column in a city.
Mm-hmm.
Just because it's horizontal doesn't mean it's not highly sophisticated engineering.
I want to go back to one detail in Image 6 quickly. The keying in. The jagged edge. It's such a messy, ugly detail that serves such an incredibly precise purpose. It reminds me that construction is just inherently messy. It's wet, it's dirty, it's rusty. But the end result, that clean gray ribbon, completely hides all of that chaos.
That's the ultimate goal of civil engineering, to hide the complexity from the user. When you drive on the finished road, you shouldn't be thinking about the sub-base compaction or the tensile strength of the wire mesh. You should just be thinking about where you're going. If the engineer did their job perfectly, the road disappears from your mind.
But today, we ruined that for our listeners.
We did. We absolutely did.
Now, every single time they drive over a bump, they're going to be thinking about cold joints.
Yeah, honestly, that's the good thing. It makes the world much more interesting to interact with.
Let's do a quick recap of the journey we just took. We started in the mud in Image 1, digging huge trenches and laying black pipes because, say it with me, water is the enemy.
Water is the enemy. Always and forever.
Then we laid down the skeleton, the rusty wire mesh in Image 2, the true bones of the road.
Tensile strength. The steel holding the brittle concrete together.
Then the actual pour. The half-road dance we saw in Image 4 to keep the greenhouse accessible, the jagged keying edges in Image 6 to lock those lanes together forever.
The logistics of flow, building the airplane while flying it.
And finally, the surface. The broom finish in Image 5 for crucial traction in the rain. The sidewalks in Image 3 for the pedestrians.
Safety and separation.
And the final result. The silver hatchback in Image 9 doesn't have to destroy its suspension anymore. And the guests arriving at Hermitage Bay in Image 10 get a perfectly smooth ride to paradise.
It's a complete transformation of the landscape, from a muddy, impassable track to a modern, reliable thoroughfare.
It really is. You know, we often talk about technology on this show, software, AI, gadgets, but concrete and steel, that's the original technology. It is the core hardware of civilization.
It creates the physical network that allows literally everything else to function. You can't have your Amazon delivery without the road. You can't have the ambulance arrive on time without the road. It's foundational.
So, here is a final thought for you to chew on as you go about your day. Next time you are driving through your own neighborhood, or maybe you see a road crew working on the highway with those bright orange cones.
Take a real look at the cross-section if you can. Don't just look at the traffic backing up.
Yeah. Look at the layers. When you feel a little bump where the pavement changes or you see a groove in the concrete, remember that wire mesh hidden inside. Remember the rusty steel holding it all together against the earth moving beneath you.
And ask yourself, if we stripped away the asphalt or concrete in your own street, what story would the layers underneath tell? What pipes are down there? What old trolley tracks or cobblestones might be buried under the modern surface?
Every single road is a history book if you just dig deep enough.
Absolutely. It's the geology of the Anthropocene.
That is going to do it for this deep dive into the anatomy of a road. We hope you never look at a pothole the exact same way again.
Drive safe out there.
We'll see you next time.